current means the rate of flow of charge. So current is equal to charge by time. So charge we denote by Q and time by T. So coulomb, the Q, the charge unit is coulomb, and T, this is time second. So coulomb per second is the unit of charge, a unit of current. So coulomb per second also we can write ampere. So always you remember when current means electrons are flowing. When electrons are flowing in this direction, always x to y, always remember current will flow from y to x in the opposite direction. So now if one question come, if n number of electron flow from A to B in t second, find I means the current. So n number of electron, so one electron mass is given here, that is one electron charge is given here 1.6 into 10 to the power minus 19 coulomb. So how many electrons are the n number? So n into 1.6 into 10 to the power minus 19, and obviously by time means the t second. So we will denote it that NE by T, NE by T. Okay, so I is equal to NE by T. Now you see, so this is na E, this is the E, charge of one electron, that's why we have written E. So another thing, suppose from current coming from this direction and this direction. So suppose the current is coming from this direction 1 ampere, this direction 3 ampere, this is 2. So always you remember the charge will flow in this direction. I mean ultimately current will flow in this direction. I mean at any junction net inward current is equal to net outward current. So these are the inward current and this is the outward current. So we can write the outward current is equal to 6 ampere. Current has a magnitude, current has a direction, still current is not a vector quantity. Current have magnitude, have particular direction, but still current is a vector quantity. As I told you, the net inward current is equal to net outward current. So here it is the inward current, it is 3 ampere, 3 ampere. So the net outward current will be 6 ampere. There is a wire, you see, there is a wire like this. In A position, current is coming 5A ampere. In B position, current is, we have to find the position of current, how much current will flow from this point B. We know IB is equal to 5 ampere, so current does not depend upon the area. Okay, current does not depend upon the area. We can see the current is less here. The current is less here, but that's why current is doesn't depend upon the area. Okay, it depends upon the. Later we will see कि current depends on which thing, but you remember current doesn't depend on the surface area. So in this position current will be same. So now conductor, semiconductor and insulator. We know insulator is, in insulator no free charge is there, no free charge, but in conductor large number of free charges are there. Free charges are going in this direction, that's why current is going in opposite direction. Okay, but in semiconductor like silicon, germanium are the semiconductor where large number of free charge are present, but sometimes small number of free charges are also there. Sometimes large number of charges are, semiconductor means they can conduct electricity but not so good. Okay, that's why it will sometimes it will show some properties like conductor and sometimes it will show some properties like insulator. So large number of free electric charge can pass sometime, but small number of free charges also can pass. Achha, now we will learn about the potential difference. Potential difference means suppose higher concentration to lower concentration something is flowing, that is the potential difference. So work done in moving one electron or one charge from A to B position. So how much work we have done from taking a charge from A to B, that is the 1 coulomb. So potential difference is equal to W by Q. Potential difference is equal to work done by per charge. How much work we have done by taking one charge from position A to B, that is the potential difference. So work done is joule and coulomb means Q means the current is coulomb, so joule per coulomb. So work done if 1 joule, so find the potential difference. We know potential difference is equal to 1 joule by 1 coulomb, that is 1 volt. So if current is coming from A to P position, we are taking current 50 volt to 30 volt in position B. So potential difference is 20, right? Potential difference we know delta V, delta is means the change of potential difference. W by Q, we know potential difference 50 minus 30, 20. Work done we have to find, and how much charge we have to bring? 2 coulomb. So 2 electron charge. So work done is equal to 40 joule. So another type of sum, A to B. Suppose Q charge we are taking. Q charge we are taking from U to B. So what will actually? So we are taking potential difference, we know W by Q, work done by charge. So position A to B. So potential difference obviously B minus A, just like this, B minus M is equal to W A to B by Q. Because we know if charge will go in this direction, then current will flow from this direction. That's why it is written A to B by charge. Similar thing, suppose X to Y, from Y to X we are taking Q charge. We are taking Q charge from Y to X. So potential difference will be Vx minus Vy is equal to work done Y to X by Q. Clear? This way. So this is about the potential difference. Now we will learn about the Ohm's law. Ohm's law we know that is the potential difference is directly proportional to the current. Okay, if current increase, then potential difference will also increase. So you see there is a conductor where there is a 10 volt and there is 0 volt. So this is a potential difference. This is less, this is high. Achha. So current, electron is moving in this direction, then current will go in this direction. So here 1 ampere current. In next we have increased the potential difference. There is 0 volt, there is 20 volt. If potential difference increase, then current will also increase. That's why it is before 1 ampere, now it is 2 ampere. 2 ampere. So there is a graph. So if we increase the potential difference, the current will also increase. So it doesn't depend, the Ohm's law doesn't depends upon the temperature. It remains constant in every temperature, and all the physical condition remain same. At that time Ohm's law will be applied. So we have learned that potential difference is directly proportional to I. So now here we know if we take any proportional sign, when we remove this proportional sign, there will be a constant, and here we have taken the constant as R. So Vi is equal to delta V is equal to IR. So R is the resistance, and you know the value of R constant for a given conductor. So from this equation we can conclude that R is equal to potential difference by I. So potential difference is equal to V and I ampere. So we can write that it is Ohm. Okay, Ohm, or the sign is like this. This is the unit of resistivity. R does not depend on delta V or I. R is constant. It doesn't depend on delta V or I, but it is depend on the conductor through which it is passing. Okay, so it is, suppose it may be silver, it may be water, so that thing it's depend. It doesn't depend on potential difference, or doesn't depends on current. So now if we another thing you remember, Ohm's law is only valid for the ohmic conductor. Water is not followed. Water is a conductor, is not a ohmic conductor. Okay, so Ohm's law is valid for ohmic conductor, and most of the metals are follow this Ohm's law. Okay, except fuse. So if we draw the slope of Vi and versus I graph, so the slope will be like this. Slope means the angle, in which angle it's make with the positive axis. This is the x-axis, we know this is the x-axis, this is the y-axis. So in x, with the x-axis, this angle, how much angle it forms, this is the slope. So slope is equal to tan theta. Tan theta means y2 minus y1 x2 minus x1. It is the formula of if we find the formula of slope, this will be the formula. Okay, now we will do some sums. So there is a conductor, the cross section area is A and length is L. So we know resistivity is equal to rho L by A. Rho L by A. Rho here the resistivity, R is the resistance. Big R means the resistance, rho is the resistivity into L by A. So this is the formula. This is very important formula. So suppose there is a two wire, one is the copper wire, this is also a copper wire, this is thin and this is thick. So we have learned for resistance is inversely proportional to 1 by A because A is in denominator, but it is directly proportional to L. Okay, it directly proportional to L, but it is not directly proportional to A, means the area. So you see there is two copper wire, this is thick, this is thick, this is thin. So this is thick means the area of this cross section is more. If more is the area, resistivity will be less because it is not directly proportional. But here you see this is thin wire, so area will be less, so resistivity will be more. Now same for the next one. There is a silver wire, this is silver, this is long, this is short. We know resistivity is directly proportional to the length, so here the resistivity will be more, here this is less. Okay, so now there will be some sums we will do. Two wire is given, suppose this is a copper wire, the resistivity is given 4 ohm. So we know the formula of resistivity is equal to rho L by A. So we know the value of resistivity R, so we have put this in this formula. We put the value R here. R is equal to 4 and rho L by A. And this is another copper wire, the 2 ampere current is flowing and length is same. So we know the resistivity of this copper wire, this is L dash, this is first copper wire, this is second copper wire. So here resistivity R, here resistivity R dash. So R dash is equal to rho L by 2A, and you know this rho doesn't depends on the it's same for the value of rho is same for the same wire. Suppose this is also copper wire, this is also copper wire, that's why the rho will be same. So R dash rho L by 2A, because it is 2A na, this is area is 2A. So this is given in the question. So here you see rho L by A, I have written it together, and 1 by 2 means separated likhechi. So rho L by A, we know the rho L by A value is 4, so I have written the value 4 into 1 by 2 to cut, so 2 ohm is the answer. Next, another question is there. A wire of length 10 cm has resistance 2 ampere. A wire of length 2 centimeter, wire of length 10 centimeter, this resistivity is 2 ohm. So resistivity is 2 ohm. We know the formula R is equal to rho L by A. So rho L by A is equal to 2. And there is another wire whose you can see the length is double, this is 2L, and area is A dash, here area is A. So rho will be same because they are made up of same wire. I told you rho value is same if they are made up of same wire, and same if they are both are copper, then their resistivity will be same. So R dash is equal to rho, this is 2L. Now we know the formula rho L by A, but here L is equal to 2L, that's why I have written rho 2L by A dash. Here the area is A dash because both the area are not same, A dash. So rho 2L by A dash is, here it is written, if the wire stretches to double of its length. Double of its length means area will be half. Okay, how we find this area will be half? Suppose আমি এই যে ওয়্যারটা এটাকে আমি স্ট্রেচ করে 12 করেছি, মিন্স এর ভলিউম আর এর ভলিউম সেম। সাপোজ এর ভলিউম V1, এর ভলিউম V2, we know volume is equal to length into breadth into height. So length into breadth means the area and height means the length here. So V1 for this wire, length into breadth means the area A is equal to length is L, and for this wire the volume is V2, but we know length into breadth into height. So here length into breadth means the A dash, this is the area, and length, this is the height, means 12, that's why LL cut from both sides. So A is equal to A dash by into 2. So A dash is equal to A by 2. So we have find the value of A dash. So we put this A dash value here. A dash is equal to A by 2. A by 2. So row 2L, and if you, this will be 2 by A. So if we arrange the formula row L by A, 2 2s are 4. So row L by A, the value we already know, that is 2. So I have written here 2 and into 4, that's why 4 2s are 8 row home. So you will see this type of sum will come. So after ending my video, you repeat the video again and again, and you watch the same video repeatedly, then you will understand. Aware of resistance 9 ohm, it's double aware of resistance 9 ohm, it's doubled on itself. Find the new resistance. So aware of length, this is the R is equal to row 9 row, R is equal to 9 row. This is the value of length. It's double itself মানে আমি এটাকে এই যে ওয়্যারটা, এটাকে আমি কী করেছি না, আমি এরকম ভাঁজ করে দিয়েছি। ভাঁজ করার জন্য দেখো কী হচ্ছে, আমি ফোল্ডেড করে দিয়েছি। সেম লেন্থই আছে, কিন্তু আমি ফোল্ড করে দিয়েছি। এটাকে ফোল্ড করে দেওয়ার জন্য এটাকে হাফ করে ফোল্ড, মানে এটাকে হাফ করে আমি ফোল্ড করে দিচ্ছি। দিস লেন্থ উইল বি L by 2 অ্যান্ড দ্য এরিয়া দিস ইজ A অ্যান্ড দিস ইজ A, বিকজ আমি এইটাকেই ফোল্ড করেছি। তো এরিয়া A মিনস 2A অ্যান্ড লেন্থটা এটার বলে L by 2. So for this one, R dash is equal to row L by A. We know our resistance is given 9.